Hey everyone, in today's episode, we are continuing on with football, but this time college football, as it is right around the corner. I'm excited for it. I know you are excited for it. And so today I'm going to show you how to build just a very basic, simple college football wins model using offensive and defensive EPA per play. EPA, if you do not know, is expected points added. It's a model built in to basically every play has expected points. And the best way to describe this is getting 7 yards on 3rd and 5 would be considered more valuable than getting 7 yards on 3rd and 10, right? Because now you're facing a fourth down. The expected points kind of differs from that because you're continuing your drive if you get 7 yards on 3rd and 5 versus, you may have to punt or kick a field goal wherever you're at in field position. And it also combines in field position as well. I don't want you to think that it does not, but that's in essence what EPA is. It just gives value and weights to the amount of yards you gain on a certain play, like that example again. So to get started, well, actually, before we start coding, is I'll pull in cfbfastR for you. That should be on the screen. We're going to use cfbfastR, so feel free to install it using install.packages, or if that doesn't work, just follow the GitHub version. I'll just show you, like, this says Pacman, pload current gh. I'll use DevTools install GitHub. Either way works to be able to install it if this doesn't work. Uh, but for the changes, this is what you need to follow to be able to access this data. You need an API key. Go to the college football data key registration. Just click on this link here and then follow this construction here to be able to put it in your environment. This is the simplest way. sys.setEnd CFBD API key, and then in quotes your API key. And I'll show you here in a second how to ensure that it works. That it populates. But first, again, DevTools install GitHub, and then that's where you can use that cfbfastR uh, code here. Now, I'm not going to run this code, but feel free, if you don't have the package installed, run it. So I will comment this out, and then we will go into, let's make sure our session is restarted, and we will go into library cfbfastR. So wait for that to finish loading. So cfbfastR will also pull in tidyverse. That is one where if you don't have it as well, I'll stick it up here. That's simply just install that packages tidyverse. Let me just volume slightly. And so it should give you, if it gives you warnings, again, not an error, you don't have to worry too much about it. The version that was built under. You may have a different R version again. So the CFBD play by the data actually has quite a few of interesting bits of info. So what we'll do here is we'll load in the play-by-play data. And what we'll do is we'll get the play-by-play data of the last, we'll say 5 years. So CFB FastR load, CFB PVP. This I guarantee you will take a little bit of time. Again, it's loading entire seasons worth. So from the 2020 2021 season, 21-22 season, 22-23, 23-24, and 24-25. That's 5 years. So again, this might take a minute. And while that's loading, we can actually set up our code. So to get win-loss record data, we can go through stats.ncaa.org to be able to pull in the FBS data for the last 3 years. So, that being said, let's do that. So, let's call in our season IDs first, which all you need to know is this goes from the last 3 years. And you'll see why I'm going to use the last 3 years in a second. But the season ID, this is the 24-25 season. This is the 23-24. And then this is the 22-23 season. And then you have just your URL, but we'll create a function out of it. So we'll say scrape CFB records function and then ID. And this is where we'll do URL. So let's actually add in XML2 as a library and rvest. Again, if you don't have them in storages, you can do XML2 and same for rvest. Just remove that pound sign to be able to install those packages. So then URL, create a page 0. I'm going to copy this URL here, but then replace it with ID. So then we can get the win-loss streaks. I'll also show you what this looks like. Go here, boom. Give it a second to load. While the PBP is loading, I'll show you kind of what it looks like in terms of win-loss. So you see, like, this is all the FBS teams. Now we might have to do some joining because the team names might be a little bit different, but that's fine. We can do that. Win-loss, and then their win percentage. So let's go back into our still loading. This is how you know it's still loading. Again, it's going to take a little bit of time, but we can still set up other code there. So we'll just call this like a payload. We'll say URL XML2 read HTML and then table timeout of. So it looks like there was a timeout of data. So I'll have to rerun this. Again, it should work. Now this doesn't have the full data set, I don't believe. So just feel free to rerun it. We'll just continue on. So then we'll say table payload rvest HTML nodes table and then rvest HTML table term equals true. And then since we're creating a function, we want the function to return something, and we'll return the table. So now it looks good after rerunning it. That's better. Again, if you get that warning message in terms of the timeout, that just means one of the years, in this case 2022, wasn't fully loaded. So just rerun it, should work, and be able to have that. So now that we have that function, I'll show you what to do with that function. I'll just say year 24, which is the 2024 season. Scrape CFB records, and then 18383. And so when you look at it, you'll see 404. Well, forgot that's what it was. Forgot the slash there. Now I should run it, should work. Now it gives you a list of a table. So what we can do in here is just go boom, piping operator 1. So essentially we're reading the HTML of the page and we're grabbing the table listed. There's one table, then we're getting that table, but then it puts in a list. So then we're grabbing the first of that list, which gives us the final table. So now we'll run it again, and it should give us, instead of a list, that table. Now we have, weird looking stats, especially overall, but we can do it this way. So let's actually grab the last 3 years. So we'll just say 1 to length, season IDs. So we're going to actually pull in the last 3 years of this data. And we'll say per mapdf. But actually, before we do that, we'll say table dplyr select table, and then we will just change the column names over. So like we'll say team equals 2, 2 referring to the second column, and then win-loss equals 4. Again, we just want the overall win-loss table. So then per mapdf function x, we'll say scrape cfb records id equals, or season IDs, and then with a bracket x. So what this is doing is just looping through the last 3 years all in one line of code to be able to pull, hey, I want, the last 3 years. I want the 22 season, the 23 season, and the 24 season. So we'll run that. Well, let's get the season IDs in there. Now we run it. And so now we have the data. But then you also notice that there's no year behind it. So obviously we want the year behind it. So then let's go in here. We'll add a mutate called year equals case when ID equals this 2024. ID equals 183 2023. ID equals 17960 2022. So that way we can get the CFB records, and it allows us to mutate. Well, we also need the year itself in the final call. So we'll add that. Now we run it again. That's right. So since there's technically duplicate names, let's just do it this way. So we'll take this out, put this in here. So we'll put table piping operator and then run the mutate year equals case when the ID is 183383 2024. It's that one 2023 and then that one 2022. And so let's take out that as well. Now we should have there we go. Filter it out. Say dplyr filter team does not equal team with a capital T, so we can get rid of that first row. Now there's other ways of doing it, but just we can do it that way as well because I think it repeats for the other years. Yeah, so if we filter out those years, then we can get those. 3. Again, we're just predicting wins based on EPA. So you can see like some of these names are shortened too. We'll fix that as well. But first, let's go back into the function one more time, and we'll say wins. We'll do a gsub call, which a gsub is basically we're taking, in this case, what comes before the call and subbing it out. Now, not 100% sure that's the right way to do it. Might be the other way. But then it gives us so year uh, wins or year team wins. Okay. So now we'll yeah, I mean keep adding to the function, but hey, the function helps wrong way. So it's technically g sub dash period and then the asterisk. So what this is doing is it's taking what comes after the dash and just removing it. So then that way we get wins. Now you see it shows character, and obviously we don't want that. So we'll add into the function wins.as numeric wins. That way it's a numeric column. So when we do get the predictions, we get the numeric value. So now it looks good. We have the last 3 seasons. Now with that play-by-play data, we'll just say, since it's, quite a bit of data, over 1 million rows, we can filter this down. We'll just call this EP shortened. And what I like to do to analyze the data is then we'll take like, the first 1,000 rows or so. And then we have our year, week. So now we have all of this data. And so our goal, you can see this play-by-play data is ginormous. I mean, when you type in call names VBP shortened, you have about 330 columns. Now, I'll let you explore. Let me know if you want me to help you explore. But the moral of the story is we'll be focusing on EPA, which is again expected points added. So this is offense, this is defense. We can do a special teams one, but for now we will do just offensive EPA and defensive EPA. So now what we'll do is we'll create those data sets. Now also, since this is just for FBS teams, we do have to filter out those non-FBS teams so that way the model doesn't get messed up when it's taking in, an uh, FBS data. So there's 2 ways of doing this. The simplest way is we'll create a vector that I already have. So feel free to pause this video and just type that out or with the provided code. But this gives you all the FBS conferences from the last 5 years. RIP Pac-12, though it's coming back. Uh, but it gives you all the FBS conferences, especially the Western Athletic Conference that no longer is around. But it gives you that kind of data. So now what we're going to do is split the data set into offensive EPA and defensive EPA and fill it by, the year. So what we're going to do in anticipation of this model is we're going to do like a 3-year weighted average. And so feel free to pick whatever value you want. I'll just go with, the like if we're trying to predict wins in 2023, we'll take EPA offensive and defensive from 2020, 2021, and 2022. Now, thankfully, it's on a per play basis because if you did full EPA, 2020 could be skewed because some conferences like the Big Ten only played half the season in 2020. So, with that being said, let's discuss how we're going to achieve this. First, let's get the offensive EPA. So I'll just call this off EPA play by play piping operator, and then dplyr mutate. We're going to create a new column called just play offense, which is just was it an offensive play? And so we'll say case when pass equals 1, then 1, rush equals 1, then 1. And either way, if it has a sack, a fumble, an interception, things like that, looking at the data set, it still has it listed as either a pass or a rush. So then we'll just say case when, so it's going through those different cases. If the pass column equals 1, because it's referring to the column pass, which is somewhere in here. So like right here, pass. If that column row is 1, then it's a 1. If same for rush, it's a 1, and it's a 1. Otherwise, it's not an offensive play. And we'll also do a filter. So again, we only want offensive columns. So play offense double equal sign 1, and then offense conference, another column, the conference that you are in D1 comms. Now, I just put D1 comms because that's me from a baseball side of things. Makes it easier. If you want to accurately name it and put FBS comms, go ahead. But it still does the same job. So it's keeping those FBS conferences and then only offensive plays. Now we're going to group by year and then POS underscore team, which is possession team. And we'll say dplyr summarize plays equals n. So n parentheses just first how many rows fit that grouping. So for each possession team and each year, how many plays do they have? And their EPA, which is some EPA, will remove NAs. So NA.rm equals true just removes any NAs. The data set's not always super clean. Then we'll ungroup it, create a new column, which is just off EPA underscore EPA play, which is offensive EPA per play. We'll say round EPA divided by plays, round to 3. Then we'll select year team equals possession team. So we'll change the name possession team to team and then off EPA play. So then click on it. Well, run D1 comps first and then do it. And now you have EPA per play. So based on this, LSU has the highest EPA per play in 2023 with a 0.366. And then you see Oregon up there in 23, Kent State in 2020, pretty high up there. Coastal Carolina, 0.308. Alabama in 2020, 0.29. The list goes on and on. Ohio State, the defending national champions, are up here at 18. So they have the 18th best EPA per play. Raw EPA per play in history. So now we'll essentially do the same thing. Maybe I won't copy it because it's actually no. I'll copy some of it. So now instead of play offense, we'll say play defense, which same thing really. You could keep it as play offense, but don't want to confuse you. So If there's a defensive play, which is again, if the offense can get a rushing or passing play, even if there's an interception, a sack, a fumble, it's still listed as one of those plays. So, from my assumption too, is like if the quarterback, it's a botch snap, the quarterback it's a fumble immediately, they call that a rush play. So then we'll filter by defensive play, and now instead of offense conference, defense conference. And then we'll say dply our group by. We'll change a name in here too. Say year and then def team equals def possession team. So again, that's just who's on defense. And same thing. We'll take plays. This time we'll call this defensive EPA. And we'll take the sum of the defensive EPA. Ungroup again. If you don't want to use the dplyr double colon, don't feel like you have to. You can just write it out. That just shows you what package it's from. dplyr under the tidyverse package. It's one of those pseudo packages within the or ungroup dplyr mutate defensive EPA per play. We'll do the same thing. Def EPA plays 3. And then essentially the same thing, year team equals defensive team, and then defensive EPA per play. Let's see. Now, to be able to get the quote-unquote moving averages, because for 2023, we need 2020, 21, and 22 for the last 3 years. So we're going to take the last 3 years of EPA data to predict the future year, if that makes sense. And then we're going to go from there. So, let's see. We'll just call this all left join off EPA and then defensive EPA by combine year and then team. So now we should have our data set where it's got every team and their offensive EPA, and then on the defensive side, a negative EPA per play is better, not a positive. That just usually means you're on the wrong side of things. But, or is it? Because Notre Dame is up here, Texas is up here from last year. I think it's the other way around. Yeah. Which works. So this is just raw EPA play by year, offense and defense. Now we'll just say like EPA, or we'll just say EPA Pred 23. And what we'll do, a unusual way of doing things, but it kind of makes sense in my mind because I don't want to average an average, if that makes sense, because technically we're averaging an average for the last 3 years, but we can do it this way, just copy, paste, but instead we'll say possession team, and we'll say dplyr filter year is in 2020, 2021, 2022. And then EPA Def Pred 23, same thing. We'll take that and be able to build that out. So we will revisit this again tomorrow as I am out of time. But it gets you the prediction. So actually, let's take out year just so we have it. Year, I guess we'll say for year equals 2023, even though it's 3 years. So we'll take year 2023 here. Oh man, I forgot the year in here. Okay, so same thing, year 2023. So now this is the EPA per play of over the last 3 years for these teams to predict their wins. So like Ohio State from 2020 to 2022 on a per play basis had the best offensive EPA per play. And then defensively, Miami, Ohio. Now, Southern Utah is in there, so something's up there. I see. I think the WAC went FCS, if I'm not mistaken. Continuing on, we will grab 2024 and essentially just copy and paste the same way we did 2023. So, without further ado, as they would say. Actually, before that, let's do this. All EPA Pred 23. We'll just join those data sets together. So EPA Offensive Prediction 23, EPA FPred 23, and then by year and team. So that way it's joined by both year and team. So the year in this case is 2023. Now let's do 2024. Again, looking at this, we're literally just going to copy and paste. I'll just say 2024. And then I'll change the years. So now instead of the 3 years prior to 2023 being 2020, 2021, 2022, it's now 21, 22, 23. We'll change this year of 24. I think that should be it on the offensive side. And then same on the defensive side. Again, I'm just going to copy and paste, saves time. 23. So again, we're just getting offensive plays, defensive plays, getting that EPA on a per play basis, joining the data sets together. So that way we have all EPA Pred 24 now. Again, same thing. But this time with the 24 data of the preceding 3 years. So feel free to change it or something like that where you can create that preceding 3. Now this is a full preceding 3-year EPA. If you want to add weights, feel free to do so. That way, like the most recent years are more weighted than the non-most recent years. So that being said, let's now first we will run this the all EPA for 2023, and then pull the 2024 in, again, the preceding 3 years. And then the EPA pred 24. And so now we'll just put it all together by using bind rows from the dplyr package. So dplyr bind rows, all EPA pred 23, and then all EPA pred 24. So now we have from the previous 2 seasons. Now, the difference, I'll show you an example. So like Arizona State, right, is spelled out in this, whereas in the last 3 data set, Arizona State is kind of shortened. So how do we combat that? What we can do is create, basically, it's called a G sub, which basically it's just regular expressions, and we're going to take a certain regular expression and convert it into the full name. So instead of state period, it's full out state. And you'll also see in here, who's another good example, like Florida Atlantic. Florida is shortened. So what we'll do here for the last 3 data set is we will create a G sub where we'll kind of affix for that. So let me show you how to do that. So team equals G sub state in quotes, and then full out state, and then team. And lastly, you want fixed to be true. So basically what R is doing here is looking at the short 3-character word of state, finds it in each instance and replaces it with the full word state. And the fixed equals true part is meaning it has to match that exact character. So state with a period. In case there's like, if there's like a team that their name is like West Alabama, that's a Division II school, West Alabama. Technically, if it was fixed equals false, that ST would be replaced with full on state, even though that's incorrect. So now we just keep going down the line. So Florida, and I'll just show you, or you can look through the data set and see which schools have, or I should say, which states have kind of like the shortened version of things, or you just follow along. So feel free to copy and paste this for each one and then just changing it ever so slightly. But Georgia, Kentucky, who else we got? Michigan, and then now we're going to enter a case when scenario. I was getting a little ahead of myself. So case when, if you understand SQL, it's pretty much, it does the same doing here in dplyr version and R. Basically goes through each instance and says, hey, if this matches this case, change it to this. So in this case, we'll go back. So like Army West Point is the full spell out based off the NCAA stats page. However, on here, it's just plain Army. So what we're saying is if team equals Army West Point, change it to Army. And so that tilde sign basically means, hey, change it to this. So a little bit different than an if-else statement, but it gives you that idea of saying, okay, if this team equals this exact option, like FIU, change it to Florida International. And again, similar to the G sub from earlier, I'll just type out all the teams that have these ever so slight differences so they can match the data set from cfbfastR. So like Hawaii has for NCAA stats, it's with two eyes, no apostrophe, whereas for cfbfastR, it does have an apostrophe. And then same, so like Miami, Florida is just Miami, since that's the default. And then you have NIU, which is just short for Northern Illinois. San Jose State, which is technically, so I'm going to copy this because I'll show you in the data set here. Actually, I'll just do it up here. So when I type in San, there's this little accent mark over the E, which is grammatically correct. But sometimes, for stats pages, it's a little bit harder to render it from a programming standpoint. So we'll just change the team name to match again cfbfastR. And then for whatever reason, I think they changed it recently, mainly because there can be confusion, but me being from the Midwest, I always thought USC was Southern California, but again, you can make the argument USC could be uh, South Carolina. I know there's some schools like a Division II school. There's USC Beaufort, which is South Carolina Beaufort. So there's kind of that interesting dynamic. So the NCAA stats refers to USC as Southern California. That's just kind of my two thoughts on that. Uh, so now we continue to go down the line. Team equals Southern Miss. So again, Southern Miss has a period. I guess I could put it up here, but since it's just that one instance, I'll just do it with the case when. Again, up to you. ULM, which is short for UL Monroe. And then the last part of the case one is true tilde sign team. So basically, how this works is if it does not match any of these cases, Army, West Point, FIU, so on and so forth, the default will just go back to team. So boom, there's our last three. And then our all EPA pred is our left join, all EPA pred. And then last three by, again, same thing, team and year. So that way we can join the data set. And now it should be over here. Oh, there we go. So we might see some NA for wins or some NA for defensive EPA per play. I will need to check that. What's going on there? Because that shouldn't be happening. But I'll double check that. Um, but there's some NAs, like Abilene Christian, Southern Utah, Stephen F. Austin, Tarleton State. Again, that's from the WAC, because at one point in time, the WAC was an FBS conference, but now they are FCS, and now they're disbanding completely. So, I see. So, the reason why is for the all EPA Pred 24, it should have been 24. So that is on me. And if you caught that before I did, great. So now we should have it fixed. And now we can look back in there. So yeah. And the only ones left are the WAC schools. So if you want to get rid of that, we'll say dplyr filter is.na wins. So basically this is doing the opposite. It's basically removing NA instances. If you just is.na without the exclamation point, that would mean, hey, I only want to keep NAs or data with none available. So let me rerun this again. and boom, you have your all EPA prediction. Now we can create our basic model. Again, the EPA is for both offensive and defensive is the preceding 3 years up to that year. So what your EPA per play was for the 2023 season takes the last 3 years. For 2024 takes the previous 3 years, so on and so forth. So let's create our model. And again, like this can kind of help you show maybe some limitations with the model. It's just a basic, again, it's a basic idea model. So we'll create this wins equals offensive EPA per play, defensive EPA per play, and then our data set, of course, is the all EPA. So we run that model. So we're creating an LM. Wins is the thing we want to predict on, and then the variables that we want to predict are the offensive and defensive EPA per play. And then we'll say data. What data set we want to use is that all EPA prediction. Now, if you want to summarize the model or kind of view it, we click on summary model, and it gives you your formula, residuals. We won't talk much about residuals right now, but we'll kind of focus more on the coefficients. So anytime, if you go back to your stats class, the p-value of 0.05 or lower is considered significant. In all these cases, every bit of the model is considered significant, which is good. Now, that doesn't mean like, hey, this is a great model. It can lead you in the right direction. And then you have your R squared, which is 0.146. So there's a little bit of a relationship with this. But basically, if you want to look at it this way, so the estimate is 6.6868 for the intercept, and then the offensive EPA per play is 11.01, and the defensive EPA per play is 10.28 or 10.29 rounded. Sorry. So basically, how that works is if you have a 0 offensive EPA per play and 0 defensive EPA per play, so let's just say it is net 0, you play the entire season and you don't have a positive or negative swing either way, you are expected to win 6.7 games. Now, round it up, again, you do a simulation 100 times, 70 of those are going to be 7 wins. 30 of those are going to be 6 wins, give or take. Now, so then for every positive EPA per play, you technically get that multiplied by 11. And then for defensive, multiplied by 10.29. And so the higher, obviously, the higher, the better, the more wins in that scenario. So let's take that scenario. So I'm going to, again, copy over 2024 and replace it with 2025. So now we're going to do the 2025 model and replace that. So now we have 24, 24. Let's do year is 25, 25. And make sure these get changed to 25. And make sure that looks good. Again, we're just redoing the same thing we did for the previous 2 years, just to have a data set of 2025 of the preceding 3 seasons of EPA per play in 22, 23, and 24. And then join this. So now we can find all EPA pred 25. Now let's predict it. So take the model we just built and we'll say all EPA pred 25, mutate and we'll say the column that we want to create is predicted wins. And then we'll use the predict formula, the model that we built that is up here on line 154, and then comma, period. And again, period is just referring to this data set right here that we already have. So mutate predicted wins, model, comma, period. Again, period referring to the data set before the piping operator, because that piping operator can revert back to the data set that you have. So we'll run this, and you can see predicted wins for every team. So if you look at it this way, based on this model, Ohio State is predicted to have the most wins because of the last 3 seasons. They had a pretty good, pretty high offensive EPA per play, and then a pretty good defensive EPA per play. And then you have Georgia at predicted at 9.5, Penn State predicted at 9.3, Oregon predicted at 9.2, Notre Dame predicted at 9. I guess Oregon 9.3, Notre Dame 9.2, Michigan 9.1. Wow, 4 Big Ten teams predicted that high. And then you have Washington that's up there. But to, again, to display this basic model, it's pretty unique to see, pretty cool to see, but obviously there's limitations because, there's going to be a team that probably reaches 13, 14 wins. And there's, again, limitations. So take this with how you will. Or, if there's ways to deviate from this and say, like, okay, maybe I can say, spin it this way and say, okay, Ohio State's predicted to win 10.2 regular season games. Georgia, 9.5 regular season games. There's ways to go about it, but this again is just a short tutorial on how to create a basic model using college football data and using the EPA per play both on offense and on defense of the preceding 3 seasons. So hope you learned something out of this. Thank you again so much for watching. Thank you to the Patreon members who can see this live as I'm doing it and be able to see this well in advance. And thank you to everyone else who tunes in. So thank you so much for watching.